Hello children, how you are all? I hope you all are doing great. So let's continue with our chapter Physical and Chemical Changes. Now we will look at some more examples of chemical change. Some more chemical changes. Let us study some more chemical changes with the help of some simple activities. Activity 8. Aim. To show that burning of coal is a chemical change. Materials required: a small piece of coal, a pair of tongs, a burner or a candle. Procedure: hold a small piece of coal with a pair of tongs over a burner or a candle for some time. Observe what happens. Observation: the coal burns with smoke. I hope you all have seen how a coal burns. It gives out heat, light, and smoke. Conclusion: coal contains carbon which burns in the presence of oxygen. So here is the reaction. When coal burns, that means it reacts with oxygen, it forms carbon dioxide. So we can conclude that coal is made up of carbon, which reacts with oxygen to produce carbon dioxide. Present in air to give out carbon dioxide gas along with some other substances. This can be represented as follows. Coal plus oxygen gives us carbon dioxide. Thus, burning of coal is a chemical change as a new substance is formed here and we can't reverse this process. Both the things indicate that this reaction is a chemical change. This change is a chemical change. Note: burning of a substance is always a chemical change. So children, this is a very crucial point here. All the burning reactions are chemical change. Burning is also called combustion. So now you all know what is combustion. Burning of anything is called combustion. Now let's look at activity 9. Aim. To show that a chemical change occurs on mixing baking soda with vinegar. Materials required: vinegar, a pinch of baking soda, 2 test tubes, a delivery tube and lime water. Procedure: take some vinegar in a test tube and add a pinch of baking soda. Observe what happens. Allow the gas produced to pass through a test tube containing lime water. Observe the changes taking place. For this, we will look at a video. We take a glass and add some vinegar to it. Now we'll put baking soda to it. Please observe carefully. A gas starts coming out with a hissing sound. This gas is carbon dioxide. I hope that activity helped you a lot. Observation: on mixing vinegar and baking soda, a hissing sound is produced and a gas is evolved. When the gas is passed into lime water, let us see what happens. This is lime water, calcium hydroxide. It's a transparent solution. But when we pass carbon dioxide through it, it starts turning milky. Please see carefully how it turns milky. This is due to the formation of calcium carbonate, which is an insoluble salt. So, when the gas is passed into lime water, the lime water turns milky. I hope you all see how it turns milky. Conclusion: the gas evolved is carbon dioxide. Carbon dioxide gas turns lime water milky. So this test, passing a gas through lime water, and if that lime water turns milky, is a way of testing the presence of carbon dioxide. This change can be represented as baking soda. When it is reacted with vinegar, it produces carbon dioxide, sodium acetate, and water. When the gas comes in contact with lime water, when this carbon dioxide, it comes in contact with lime water, that is CaOH whole twice is lime water, that is calcium hydroxide. When it reacts with carbon dioxide, it produces calcium carbonate along with water. So look here, lime water reacts with carbon dioxide, produce calcium carbonate and water. It forms a white solid substance called calcium carbonate, and this calcium carbonate is insoluble in water, which results in the turning of solution to milky. The change can be represented as lime water plus carbon dioxide gives us calcium carbonate and water. Thus, mixing of vinegar with baking soda is a chemical change. Lime water is a colorless liquid. I hope you all saw that. It is made by dissolving lime, that is calcium oxide CaO, in water, that is H2O, and then filtering the solution. Lime water is represented as calcium hydroxide CaOH whole twice. Let's perform another activity. Activity 10. To study a chemical change using iron fillings and sulfur powder. Materials required: iron fillings, sulfur powder, a china dish, a magnet, and a burner or a candle. Procedure: take some iron filling and sulfur powder in a china dish and mix them. Bring a magnet close to the mixture. Note the observation. Do you think any new substance has been formed on mixing iron fillings and sulfur powder? So let's look at this activity. Take a beaker, add 2 spatula of sulfur powder to it. To the same beaker, add 2 spatula of iron fillings. Mix it well with a glass rod and label this mixture as A. Take a china dish and transfer small quantity of this mixture to it. Heat the contents in the china dish strongly. Stir the mixture constantly till a black mass is obtained. Cool and transfer this content to a mortar and powder it. Transfer this to another beaker and mark it as B. Transfer the contents of the beakers to 2 different watch glasses. We'll bring a magnet near to mixture A first and see what happens. In mixture A, the iron fillings will stick to it, explaining that the iron fillings retain its property, whereas in mixture B, no such observation is observed. I hope you observed the activity carefully. Now heat the mixture containing iron fillings and sulfur powder on a burner. Observe the changes taking place. Can you see the yellow sulfur powder any more, or does it disappear? Now bring a magnet close to this. Is it affected by the magnet? Observation. On bringing a magnet close to the mixture of iron fillings and sulfur powder before heating, I hope you all know what happened before heating this mixture. When we brought a magnet near to this, we find that iron fillings get attracted to the magnet, and this explains that when 2 substances are mixed, they retain their property. So that's why iron fillings get attracted towards the magnet. And the components can easily be separated. On heating the mixture of iron fillings and sulfur powder, the mixture glows brightly and gradually changes into black solid. Now in this process, iron fillings and sulfur powder, they lose their property and forms a new substance, that is a black solid. The black solid form is very different from the original mixture. It is not affected by magnet, which explains that it doesn't retain the properties of its constituent. Conclusion: a chemical change takes place on heating iron fillings and sulfur powder. This change can be represented as iron, that is Fe. Sulfur is S, and it forms iron sulfide, that is FeS. As a new substance is formed here, iron sulfide, thus this is a chemical change. Children, now let's take a look at uses of chemical changes. Chemical changes are very useful to us. Some of them are as follows. Burning of coal, petrol, and a gas is a chemical change. A lot of heat is given out in such a change. This heat is used to produce electricity, to run engines, and also to cook food. So we can say that burning of coal, petrol, and gas results in production of energy. Many chemical changes take place when a metal is extracted from its ore. So, what is an ore? Ore are the minerals from which we can extract metal, or you can say ore are the rocks from which we can extract metals profitably. For example, aluminium and iron are extracted from their ore by a series of chemical changes. Next, chemical changes are also used in purification of metals. Next, many useful things that you use in daily life like soaps, detergents, polythene bags, etc. are produced due to chemical changes. Medicines are also a result of chemical changes. Let's see a new word, chemical reaction. A process used to rearrange the substances to form new substance with different property are called as chemical reactions. Students, let's deal with some question answers. Ninth question. Represent the chemical changes that occurs on A. Burning a magnesium ribbon. I hope you all can answer this. When magnesium reacts with oxygen, which is called as burning, it produces magnesium oxide. B. Mixing magnesium oxide with water. When magnesium oxide is combined with water, it produces magnesium hydroxide. C. Reacting zinc with dilute hydrochloric acid. On reaction with dilute hydrochloric acid, zinc produces zinc chloride plus hydrogen gas. D. Reacting copper sulfate and an iron nail. In this reaction, copper sulfate when combines with iron nails, it produces ferrous sulfate along with copper. E. Reacting iron fillings with sulfur. In this reaction, when iron combines with sulfur, it will form iron sulfide. Children, you have to copy all these questions from the PDF provided to you in your notebook. I hope you enjoyed today's session. Keep smiling, keep studying, and have a wonderful day.